Okay, another property of liquids, besides the several we've already talked about, is that they can undergo something called vaporization. What is vaporization? Well, it is simply the process by which a liquid or solid changes into a gas. There are a couple of ways that liquids can undergo vaporization. The most common thing that we see of liquids undergoing vaporization is evaporation. Remember our nice little song in the water cycle. Water cycle is totally dependent upon liquids' ability to evaporate, water specifically. Evaporation, and I'm going to have you guys do a little experiment about this. But evaporation happens when the particles on the surface of a liquid accumulate enough energy, absorb enough energy, that they actually turn from a liquid into a gas, and they escape the surface of the liquid. But notice that with evaporation, we're talking about non-boiling liquids. How does this work? Well, here's a nice little picture here. And you recall that all atoms and molecules are vibrating and moving. They all have kinetic energy, except at absolute zero. Okay, so all of these atoms and molecules of this liquid, you could call it water, I guess, are constantly moving. Now, the ones at the surface are not just absorbing energy from the motion of the atoms in the liquid, but they're also absorbing quite a bit of energy at the surface, right? Especially in situations where they have the sun shining on them and they're heating up quite a bit. They're not boiling. It doesn't heat it up to, 100 degrees Celsius, okay? But they're absorbing heat from the air around it, or even the sunshine. And all this heat gets absorbed by the surface molecules or the surface atoms. And those surface atoms eventually collect enough energy that they turn from a liquid into a gas. So in evaporation, we're talking about the vaporization of only the surface molecules, only the molecules on the very top of the surface of the liquid. Boiling, however, is a situation where we're adding so much heat to the water. Well, we can use this. So much heat to the water. Oh, I see, this is boiling. Okay, so there's evaporation, surface molecules. But in this one, we have a situation where we're adding heat to this liquid, so much so that the temperature of the liquid gets to 100, well, if it's water, gets to 100 degrees Celsius, and then even these molecules down here below the surface start to turn into gases. And when they do that, what do gases do in liquids? They bubble, right? So that's the bubbling you see in boiling. When you're boiling water to cook pasta, you want to boil that water, get it up to that 100 degrees Celsius temperature, so that all of these little atoms, all of these little molecules in here are at that temperature, so your pasta cooks nice. Otherwise, it cooks really slow, it gets really gummy, and it's gross, okay? So, boiling happens when we have vaporization throughout the sample of the liquid because the temperature is so high. And again, those bubbles are those liquid atoms and molecules going from liquid to gas. As you know, that's what gases do. They bubble in liquids. Okay, so that's the difference between boiling and evaporation. Okay, I think I'll try to finish this. All right, liquids can also freeze. So vaporization is when a liquid goes from being a liquid to being a gas. Freezing is when a liquid goes from being a liquid to being a solid. So you remove enough energy from a liquid and it becomes a solid. Remove heat, all right, from the liquid. It can turn into a solid. That's called freezing. I think you probably pretty much know about that. We might do a little activity or something with viscosity. Viscosity is another characteristic of liquids. What is viscosity? Well, viscosity is the resistance to the deformation when you try to pour it. So you're putting this force on it, a shear stress or a tensile stress, You're putting a force on the liquid, like trying to pour it out of the beaker. And the liquid's resistance to that is called viscosity. The way I think of it that helps me a little bit is the thickness of a liquid. And another good example is to think of honey. Okay, compare it to water. If I have a glass of water and I want to pour it in the sink, it doesn't take very long. I turn it so that gravity's working on it without the glass in the way, and that water is not very viscous, pours out pretty quick. If I want to do the same thing with a glass of honey, if I have honey and I'm trying to pour it into the sink, that honey is more resistant to the force of gravity without the glass in the way. And therefore, honey is said to have a higher viscosity than water. All right, properties of liquids.